Hey everyone, and welcome back for another deep dive. Today, we're going to be talking about something pretty awesome,
hmm
India's SpaDeX mission.
Yeah.
And with us, we have an expert to help us break it all down.
Hello.
So
Happy to be here.
we've got articles from Mint Times of India and NDTD, as well as some insights from ISRO's website.
Right.
But just to kick things off, can you tell us what SpaDeX is all about?
Yeah.
What is space docking?
Well, space docking, it's actually one of the more difficult things to do in space.
Yeah, like that.
Only a handful of countries have actually managed to pull it off successfully.
Wow.
The U.S., Russia, China.
Right.
But essentially, you have two spacecraft, and they're hurtling through space at, thousands of kilometers an hour,
Right.
and you're trying to get them to connect seamlessly to form a single unit.
So like a
So
giant space handshake.
Yeah, you could think of it that way.
Like
It's
a
incredibly complex, requires a ton of precision.
right.
Any miscalculation could lead to disaster.
And India is attempting this right now, like as we speak.
Yeah, that's right.
I read that the launch happened on December 30th from Sriharikota, and the docking is expected to happen around January 7th.
Right around then, yeah.
So in just a few days, we're going to know if they were successful.
Fingers crossed.
I know I'm going to be glued to the news.
Absolutely, it's a historic moment.
It is so exciting.
It really puts India on the map as a major space power.
For sure. And you mentioned it's incredibly complex.
Oh, yeah.
So what kind of technology are they using to make this happen? How do they even guide these spacecraft together so precisely?
Well, there are a number of systems at play here.
Oh.
We're talking laser rangefinders,
Okay.
rendezvous sensors, a new GNSS-based system for super accurate location in space.
GNSS, is that like GPS but for space?
Kind of, yeah, but much more advanced.
Wow.
It needs to be able to operate in the unique environment of orbit where, you're traveling at incredible speeds
Right.
and you need to know your position down to the centimeter.
So they're basically playing a really high-stakes game of catch-up there,
Yeah, in a way.
while also testing out technology that could change how we navigate in space.
Exactly, and that's just the beginning.
Oh, there's more.
Oh, yeah.
Okay, tell me more.
This mission isn't just about docking.
Mm-hmm.
The PSLV that launched these spacecraft is carrying 24 additional payloads.
24, what are we talking about here? What kind of payload?
It's a mix of experiments and technology demonstrations.
Okay.
Everything from astrobiology.
Astrobiology. That sounds cool.
Yeah, they're studying how life behaves in space
Wow.
to a robotic arm that's designed to grab space debris.
Like a giant claw machine in space.
Pretty much, yeah.
That's amazing.
It's a huge problem, space debris, and India is trying to find solutions.
That's really impressive.
There's even a private company, PeerSight, testing a precursor to India's first private synthetic aperture radar satellite.
A private company doing that.
Yep.
That's incredible.
They're aiming to have a whole constellation of these satellites by 2028 focused on maritime surveillance.
Okay, this is way cooler than I even imagined.
It is pretty exciting stuff.
So we've got space docking, groundbreaking navigation tech, a solution for cleaning up space junk, and a boost for India's private space industry, all in one mission.
That's the beauty of it.
The SpaDeX mission is really shaping up to be something special.
Oh, absolutely. A real game changer.
So before we dive even deeper,
Sure.
what are some of the key things we should be paying attention to? What are the big takeaways so far?
Well, I think the biggest takeaway is that India is serious about space.
Yeah,
This mission is a statement.
definitely.
They're not just playing catch-up anymore.
Mm-hmm.
They're innovating, they're pushing boundaries,
Yeah.
and they're doing it their own way.
I'm definitely hooked. I
Yeah.
can't wait to learn more.
Me too. Let's get into it. So, we talked about how complex this docking maneuver is.
Right, like threading a beetle at thousands of kilometers per hour.
Exactly. And to make it even more challenging, they're doing it autonomously.
Autonomously. So no joystick, no pilots on the ground controlling these spacecraft.
Nope, it's all pre-programmed and controlled by the spacecraft's onboard computers.
Whoa, that's a lot of trust in those computers.
It is, but that's the future of space exploration.
Yeah, I guess you can't have someone sitting at a console,
Sure.
millions of kilometers away trying to steer a spacecraft in real time.
Right, too much lag, too much risk.
So how does this autonomous docking actually work? Talk me through it.
Okay, so imagine the two spacecraft, the Chaser and the Target, are in the same orbit, but separated by about 20 kilometers.
20 kilometers. That's like running a half marathon.
Yeah, pretty much. So the first step is what they call the far rendezvous.
Okay, far rendezvous. What happens there?
The Chaser spacecraft uses its thrusters to slowly reduce that distance approaching the target in a very specific way.
And how do they make sure they don't, bump into each other at those speeds?
Well, that's where the V-bar approach comes in.
V-bar approach.
Yeah, imagine a laser beam pointing straight out from the target.
Okay.
The Chaser has to fly along that beam, approaching in a V shape.
So kind of like landing a plane on an aircraft carrier, but in space?
Yeah, you could think of it that way.
And this V-bar approach, why is that so important?
It's all about safety and control.
Okay.
By approaching along that line, they can ensure a smooth rendezvous, minimizing the risk of collision.
So no sudden movements, just a very calculated approach.
Exactly. And as they get closer, there are a series of hold points.
Hold points.
Yeah, basically checkpoints along the way.
Okay.
They pause, check systems, make adjustments, and verify everything is on track.
So like pit stops in a race.
Kinda, but with much higher stakes.
I can only imagine.
And then as they approach the final docking phase, that's when all those sophisticated sensors come into play.
The laser rangefinders and rendezvous sensors you mentioned earlier.
Right. Those and a video monitor for visual confirmation. Wait, they have a camera watching all of this. That's awesome.
Yeah, it helps them make sure everything is aligned perfectly.
Yeah.
I'd love to see that footage.
And of course, there's the GNSS system providing super accurate location and velocity data.
Like all these different instruments working together in perfect harmony.
Exactly, a high-tech symphony.
Okay, so they're getting closer. They've passed all their checkpoints. They're lined up perfectly. What happens next? How do they actually connect these two spacecraft?
Well, the docking mechanism itself is actually pretty subtle.
What do you mean?
It's not like some giant claw grabbing the target and pulling it in.
Oh.
It's much more gentle than that.
Okay.
They use a low-impact docking system.
Low impact.
Yeah, we're talking millimeters per second.
Millimeters? That's incredibly slow.
It has to be any sudden force could damage the spacecraft or disrupt their orbits.
Right. Makes sense.
So it's more like a gentle embrace guided by latches and guides that pull them together.
I'm picturing a slow-motion space waltz.
Pretty much, yeah.
And once they're docked, what then?
Well, that's when things get really interesting.
Okay, I'm listening.
They can transfer power shared data and even prepare for crew transfers in future missions.
So the docking itself is just the beginning.
Exactly. It opens up a whole new world of possibilities.
That's amazing. And what's even more impressive is that they're doing all of this with relatively small spacecraft.
Right. Each one is only about 220 kilograms.
That's wild. Think about how much more complex it must be with something like the International Space Station.
Oh, yeah. Orders of magnitude more difficult.
But I feel like we focus so much on the how of this mission that we haven't really talked about the why. Why is all of this so important for India?
That's a great point. SpaDeX isn't just about proving they can dock.
Right.
It's about laying the groundwork for their larger space ambitions.
Like the Bharatiya Antriksh Station, their own space station planned for 2035.
Exactly. This mission is a test bed for technologies that will be crucial for building and operating that station.
So this is a glimpse into India's future in space. And it goes beyond just the station, right?
Right.
What about those reusable launch vehicles they're developing?
Right, those too. They'll need docking technology for that as well.
It's like each piece of this mission is connected to a larger vision.
It's a brilliant strategy. They're building a cohesive, sustainable space program step by step.
Okay, I'm even more impressed now.
Yeah.
But tell me, with all this talk about India's ambitions, where do they stand compared to the big players in the space race? Are they playing catch-up or are they forging their own path?
I think it's a bit of both. You know, they're definitely learning from the successes and the failures of established space programs, but they're also doing things their own way.
So what makes India's approach unique?
Well, for one, they're incredibly resourceful. I mean, they've achieved some pretty amazing things with a fraction of the budget of like NASA or the European Space Agency. You know, it's a real testament to their ingenuity.
Yeah, it's pretty inspiring to see what they're able to do.
Absolutely. And they're not just focused on, you know, prestige projects. They have a very clear vision for how space technology can benefit their people and the world.
Can you give me an example? Like, how are they using space technology to make a difference here on Earth?
We'll take their They're Earth observation satellites, for instance.
Okay.
They're providing crucial data for agriculture, disaster management,
Yeah.
resource monitoring.
Makes sense.
This information helps farmers improve crop yields.
Oh, wow.
It helps governments respond to natural disasters.
Yeah.
And it helps scientists track environmental changes.
So it's not just about, planting a flag on the moon or Mars.
Right.
It's about using space technology to solve real-world problems.
Exactly.
And we also talked about the role of the private sector, how India is encouraging private companies to get involved in space.
Yeah.
Like PeerSight with their radar satellites.
Yeah, they're aiming for a constellation of 32 of these satellites by 2028.
It sounds like India is really fostering a space ecosystem,
They are.
not just a government-run program.
Yeah. And I think they recognize that the future of space exploration lies in partnerships,
Right.
both within India and on the international stage.
So where do you see India fitting into this larger picture
Yeah.
of global space exploration?
Well, I think they aspire to be a leader in certain areas,
Okay.
like low-cost space access and innovative applications of space technology.
Right.
But they also want to be a valuable collaborator, partnering with other nations
Yeah.
on ambitious projects that benefit humanity as a whole.
It's a bold vision, but from what we've seen with SpaDeX
Yeah,
and their other achievements, it seems within reach.
I think so.
This mission isn't just a technological feat. It's a statement of intent.
It is.
India is here to stay,
Yeah.
and they're ready to make their mark on the cosmos.
I agree.
So as we wrap up our deep dive into SpaDeX, what's the one thing you want our listeners to walk away with?
I think SpaDeX is a glimpse into the future. A future where India is a major force in space.
Yeah.
And they're doing it not just for national pride, but for the betterment of humanity.
That's awesome.
So keep an eye on the skies because India's journey is just beginning.
Couldn't have said it better myself. For our listeners, be sure to check out the links in the show notes to learn even more about SpaDeX and the exciting future of India's space program. And until next time, keep exploring.